I will introduce to you our intelligent I/O box. When we open the lid, you'll find a circuit board inside. This module offers two connectivity options, wireless and wired. Let's take a closer look. On one side of the module, you'll find a power connector and 4 output channels. On the opposite side of the box, there's a wireless antenna and 4 input channels. Let's power up the module. You'll notice that it's powered when the status LED illuminates and network LED indicating a network connection attempt. To configure it, just remove this jumper. To begin configuration, connect to the module's wireless network, which can be found in the list of available wireless networks. Use the password 1234567889 and wait for a successful connection. After connecting, open a web browser and enter the address 192.168.1.25 with port 8080. The credentials for this page are both admin for the username and for the password. You'll now have access to the configuration panel. Start by entering the SSID of your network and the network password. Choose an IP address for the module, such as 192.168.1.180. Set the network mask to 255.255.255.0 and the gateway as 192.168.1.1. You can use the same address for DNS as the gateway. Enter the username and the password for the corresponding robot you intend to use. Leave the delay timeout unchanged. The modules features 4 input and 4 output channels. Provide the IP address of your robot. For instance, in my case, 192.168.1.102. While I'm here, I'd like to navigate to the map section, where I have a specific scenario in my mind. We have 3 gates numbered 1, 2, and 3. Here's what I want to achieve. When the robot approaches any of these gates, I want the corresponding gate to open automatically. This applies to gates 1, 2, and 3. To accomplish this, I'll start by creating a I/O zone near gate 1 like this. I'll set the action to PLC registers and an index of 101 and configure it as follows. When the designated robot enters in the zone 1, the register number 101 will change the entry value to 1. When the robot exits the zone, it will trigger an exit value of 0. To save these settings, I'll simply press the Create button. Next, I'll repeat the process for gate 2, creating a I/O zone and naming the device as 102. Again, I'll set it up to work in the same way as gate 1. Finally, I'll move on to the gate 3 and create another I/O zone, but this time I'll designate it as device number 103. The settings will mirror those of gates 1 and 2. In summary, I've successfully established 3 zones. Zone 1 with register 101 for gate 1, Zone 2 with register 102 for gate 2, and Zone 3 with register 103 for gate 3. Now return to the configuration page and enter the IP address for the robot. Like in my case, 192.168.1.102. Specify that output 1 is linked to register 101 responsible for opening gate 1. The same principle applies to gates 2 and 3 with different register for each, 102 and 103. Each of the 3 relays will trigger the respective gate to open. Now it's time to set up PLC registers for input channels. For instance, when input 1 receives a 12 or 24 volt signal, register 150 will change to 1. This setup applies to input 2 as well. This setup is now complete for robot 1. If needed, we can replicate these configurations for additional robots. In my case, as I have a second robot, I will configure it using the same method but assign it a different address. After configuring all settings, click the Submit button to save your configuration. You can then disconnect the power from the module. With the power off, reinstall the jumper and power up the module again. The Wi-Fi status LED should light up. The module's input connector accepts 12 to 24 volts. Ensure that you observe the input polarities as indicated on the board. You can now test the module. I will ask the robot to move to specific position. As the robot follows its designated route, it will enter Zone 1, causing Relay 1 to activate and open Gate 1. Upon exiting Zone 1, Gate 1 will automatically close. The same process repeats as the robot reaches the next zone, leading to the opening of Gate 2. This position can also be tested to ensure the robot smoothly follows the route with the gates open and closing in response to the robot's position within the zone. This demonstrates the core functionality of this module. Now let's proceed to test the input capabilities. On the dashboard, navigate to Settings, PLC Registers and check Register 150. As mentioned earlier, it will switch to 1 when input 1 detects a 12 or 24 volt signal. The same applies to register 151 when input 2 receives a signal. This versatile module is also available in a DIN rail format for easy installation in cabinets, offering the same functionality without the external casing.